All right, folks. So we're going to dive into a Z-test, but I wanted to remind you of some awesome tools that you have. Okay. We have, so on ChatGPT, I just want to remind you that it's a awesome resource because we're using so many different tests, so many different calculator functions. Um, and the big question is, when do I use what? So today in my in-person class, I talked about a Z-test. And so one of the things that I do personally is whenever I get something confusing, I have ChatGPT even give me a breakdown of what the heck is it that I just read, right? Making sure I really understand the question. And whenever you guys move forward, um, let me answer this. As you move forward, you can't until you understand the question. Let's see, let me answer this direct chat. Do, 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 do. Do, do, do. Just perfect. All right. So my question, if I'm a student, is, what the heck is a Z-test, right? So let me read this to you and kind of highlight something. So a Z-test is a type of statistical test used to determine, is there a significant difference? So is there a big ass difference between the sample statistic and the population parameter? And so when we talk about sample statistic and population parameter, we could be looking at the means, right? So that's one of our options. Or we could be looking at proportions. Or as you see, as we move further, we could compare two proportions, all right? And so it's one of the simplest and oldest statistical tests. So the Z in Z-test comes from the Z-score, which measures how many standard deviations something is from the mean. All right. So this is what we're doing. So when I say, hey, we're going to run a Z-test, what we're doing is we're saying, all right, I know something about the population. And now what I'm going to do is, I don't think that number that we used to use in the past is current. I think something has changed. And I'm going to perform this test to show that there actually is such a change. All right. When can I use it? All right. So here's when we can use it. So number one, the sample size has to be large. So it has to be greater than 30, right? We've talked about that. The population standard deviation is known, which is just like so remember the variance is just the population standard deviation squared. So one of those two things has to be known. And then our distribution has to be assumed to be normal. So these are the three things I must know in order to use this test. Later on, when we come back from spring break, what we're going to see is we don't always know the population standard deviation or the variance. So when we don't have the population standard deviation, that's when we're going to do something called a t-test. All right. So again, we have all these tools, and these tools are only helpful if we know when and how to use them. So let's dive in here and let's look at let's look at 9.2. All right, so let's do 9.2 together. And I'm going to go backwards. No, I'll just start from the beginning. Because again, you could have done this homework, but I don't want you just doing the homework. I want to make sure that it totally makes sense. All right, so let's dive in this homework together. And if you're not in my class and you're watching this, again, this also applies to you. So I'm going to show them using the calculator. If you're not in my class and your instructor is making you do it by hand, let me know. I'll be more than happy. I have videos showing you how to do this by hand. All right, so check this out. A poster approaches 44 people. Good, we have more than 30. As they leave a movie theater and ask them how many movies they have seen in the past month. So the mean is 2.3. Assume this population standard deviation, right? Sigma is 1.2. Is it appropriate to use the methods of the section to perform a hypothesis test about the population mean? All right. So there's a couple things here, and we said, a lot of you guys, I worked with you, said yes, because our sample size is large enough. And when we're checking large enough, again, we're looking at this number, which is our N. And so our N is greater than 30. All right. So when N is greater than 30, it doesn't matter. Let me show you again. It doesn't matter. So it says, yes, the sample size is large enough, whether or not the population is normally distributed. All right. And that's because of our central limit theorem. So once we have an N large enough, the central limit theorem allows us to get away from, I don't care what kind of distribution we're looking at. All right. So let's read this. And what I'm going to do is I'm going to write on here because I want to walk you through how I label everything so that you have some type of technique as you're doing, not only doing this homework, but so that you understand, so that when you're given a quiz and everything's kind of mixed together, you know how to identify everything and set up the scene. All right. So let's look at this. Let's see. Let me annotate this. Let me write on my screen. All right. So random sample of 61. So right away I go through here. There's my N. N is 61. Second graders in a certain school district are given a standardized math test. The mean sample score. So notice this score came from this group of 61 students, 61 second graders. So because it came from that group, that's why it's X bar, right? Doesn't represent everybody. And assume the standard deviation of test scores is, and notice they're using this symbol. So because this is the key right here, because they're using the population standard deviation, that's what's going to push me to use z-interval or z-test, depending on what they're looking for and what they're asking for. So a nationwide average, notice this is of everybody, a nationwide average of this test is 50. So that's our mu is 50. All right, the population standard deviation. So the superintendent wants to know whether the second graders in the school district are weaker than the national average. And again, I want to grab the 0.01. That's our alpha. All right, so the first things first, we're going to write down that mu is equal to 50. And here, mu, look what he's doing. Let me highlight this part. Let me highlight what he's looking for. The superintendent wants to know if the second graders have a weaker math skills nationwide. So I have to think about this. If it's weaker math skills, are they going to have a lower? Are they going to have a lower skill set, a lower points or higher points? What would you guys say? What would the scores be? Higher or lower?
Lower.
Right. So they'll be lower. And because we have a less than, then we know our hypothesis is going to be a one-tailed, a left-tailed test. So when I draw this, I'm going to have a left-tail test. All right. So this is what we have so far. All right. So let me hit skip part. Let's skip this part. Skip. There we go. So just like we said, right? Everything matches what we said. So let's continue. All right, the next thing they want is our test statistic. So let me go back up. So the next thing they want is something called our test statistic. So let me write this down. So now we want to find our test statistic. All right. So what program can we use to find our test statistic? What program can we use to find our test statistic? See, let's see what the chat says. Z-test. Good. So we're going to use Z-test. And so let me highlight, how do I know to use a Z-test? So notice in this problem, as we read it, here they never ask us, they don't ask us for any type of confidence interval. You know, we're just trying to see if this right here, which one of these is true, either my null hypothesis or my alternate hypothesis. Which one of these is true? And so once we get into this right here, trying to figure that out, that's when we have to run a test, right? So that's when we're going to run one of those tests, either a Z-test or a T-test. And as Shai points out, they give us a population standard deviation. So that's how I know I'm going to use, out of those tests, I'm going to use a Z-test. All right. So to use our Z-test, we're going to punch all this in. So let me share a different screen with you. Where's my calculator? Let me get my calculator ready. And let me actually load up a different calculator than the one I usually show you guys. It's a different app, but it does the same thing. I just hope that it's a little bit nicer. So give me a second, let me share this. All right. So we're gonna go to stat. We're gonna go to test and then Z-test. Oh, I was hoping it's nicer. It's not that much nicer. Or might be more confusing. I don't know. So we put in our mu right here. So it says to put on our mu. And this is another free app called TI84. It used to be free. I don't know about now. So I think our mu was 50. 50. Was that correct? Because I deleted everything. Yeah. And then our standard deviation, 50. Let's see, enter. Oh, standard deviation is 20. 20. Our sample mean, oh, I think I have to hit enter on this calculator. It won't save. Our X bar is 45. 45, enter. And what's nice about this calculator is it shows you the graph right away. N was 61. 61. And what's nice is it gives us these two pieces of information that we're interested in. So number one, I know it's super small, but we're interested in the test statistic. So 1.95. And it could be positive and negative, right? Because we have two. This is the negative side, and this is a positive side. And then it also gives us our p-value of 0.0509 if we round. All right. So this is another app, but again, your calculator does this. It gives you those two things. It gives you a lot more than this calculator. And of course, make sure when you're doing this, weaker. So make sure you choose this one, less than. All right. And so that's why our z-score here is, our test statistic, excuse me, is negative. All right. Let's say you make a mistake and you choose the wrong symbol. So check out what happens to your p-value. Notice right here it's 0.025, but if I hit two tails, what it does is it multiplies that by 2. All right. So it multiplies it by 2, so it changes it. But What doesn't change is your test statistic, but your p-value changes. All right, so I just wanted you to see that as well. All right. So just to play around with your calculator, just so you know what it's actually doing. So again, we're choosing this one because it was a left tail. So our test statistic is negative 1.95. All right, let's go back to the problem. All right, so this one we already did that, and we got the answer of negative 1.95. The next thing it asks for is the p-value. So again, once you run z-test, so you might want to write this in the notes again. Whenever they ask you for a p-value, like how do I compute the p-value in this scenario, given the information, right, that we have, you use z-test. And you know, after we get through these sections, will be a great, I think, quiz would be, I'll give you a whole bunch of scenarios and I'll ask you for different pieces of information. But I won't actually have you do it. I'll just say, hey, what program would you use? So if I asked you for a p-value and I gave you all this information up here, right? This information that you had, I would say, what program would you use to calculate the p-value? And so you say, okay, I run the z-test. Because most times when you're problem solving, right, in real life, the hard part, the majority of the time is getting started, right? Getting started is so hard often. That's where the majority of people struggle. Not you guys are here. You guys are outliers. All right. So we already did this. So let me hit skip part. And so that's what we got, 0.0254. All right, let me read the chat. Jesse manda saludos a Magdalena. All right. Not just messing with you guys. People on YouTube gonna be what? What's he talking about? Determine whether the H naught. So determine whether we reject H naught. So this is another good question, right? So how do we determine whether you reject your null hypothesis or not? So just in case you miss it, this is a good, so if P is less than alpha, that's when you reject H naught. Right. And then as Dulce said in class, vice versa. So if P is greater than alpha, then you don't reject H naught. Right. So in our situation, so identify what I like to do always nice and, I know I'm not writing neat, but I write down my p-value 0.0254. And then I look at my alpha level. This is always going to be given, the alpha level, right? Let's see, what did they give us? I think it was 0.01 for this problem. So alpha was 0.01. Oh, it has it right here, duh. 0.01.
John, I have a question.
I have an answer, thank you.
Where did you get the p-value? Isn't the p-value the same we got with the our statistics z? We have the z value minus
p-value,
195 and then p-value 0.050. It's not the same?
Let me go to our calculator and let's see. Let me share my calculator with you. So our calculator was 0.0254. This one right here. I don't know. It's really small. I don't know if you could see that. 0.0254.
I don't know. I don't know why I get a.
And just make sure you use the middle one where it says less than.
I did, actually, I had, the C value is the same, minus 1.95, but my P value is different. How come? My P value is 0.0508.
Your p-value is 0.05.
0.0508. What did I get that number?
So you got that number because, and I'm glad you're sharing this, because make sure
Ah,
yours is like this, not equals to, scoot it over so that it's less than, and then hit enter, because if you don't hit enter, it won't save it. It won't highlight it.
oh, it
Yeah,
must have happened. Yeah, that's what, yeah. Because
cool.
I thought I did, but I guess that's what happened. Thank you.
Yeah, and because that same thing just happened to me earlier. So I'm
Okay,
glad. Good, good. Thank you for sharing.
sure.
And then let me respond to we have a super chat coming from Texas. Um, all right, cool. So our p-value is greater than. So that tells us we reject the null hypothesis. So whatever that null hypothesis was, we're going to reject it. So what I like to do is, says do not reject. Our p-value is greater. Oh, our p-value is greater. My bad. Our p-value is 0.02, which is bigger than this. I just wrote it and I clicked the wrong one. My bad. So yeah, you don't reject it because our p-value is greater than alpha. Let's look at this chat. So what happens, because I didn't do one like this in class, what happens when you don't reject? So this is what's happening. Let's go to this. So because we do not reject it, we're like, you know what? We don't know if it's true, but what we do know is we do not have enough evidence to support this claim, right? We do not have enough evidence to support this. That doesn't mean that this is wrong, but based on the information presented to us, we can't say this. So what we say is, we don't have enough evidence to reject this right here. All right. So what does this mean? So the last part, like I said in class, is the most important part. What does this actually mean? So this is where you have to go and read the problem again. So what we're saying is that the mean is equal to 50, or, that this is what the evidence is kind of pointing towards. So when I go back to the problem, let me minimize this so I can read it. Let me hide this. So when I go back to the problem, I always go to the question. So the school superintendent wants to know whether the second graders in her school district have weaker math skills than the nationwide average. And so what we say is no, right? We don't have enough evidence to support this, because it went away. Let me scroll down a little bit. So we went with this one. This is our conclusion. We're going with this. And what this means is that there is no significant difference, right, in math skills. That's what our data shows, right, when we do this test, right? So we don't have enough evidence to support the claim, right? We don't have enough evidence to support the superintendent's claim that second graders in her school district have weaker math skills than the nationwide average, right? So that is what we're gonna write at the very bottom. So let's go to the very bottom so you guys can see the grand finale. So we say there is not enough evidence to conclude that second graders in the superintendent's school district have weaker math skills than a national average. And again, this is because, we do not reject the null hypothesis. If we would have said we do reject the null hypothesis, then we would change this to there is enough evidence. But because we're saying we do not reject the null hypothesis, then we don't have enough evidence to support that superintendent's claim. All right. So is there questions about that before we jump into another question from the homework? So if you want, what you could do as you're following along, I don't know if this is a good idea or not, you tell me, but you could even open up you could open up your question number 3 with me, and we could try that together. Your numbers will be different, but we could kind of do it together. So let's look. All right, so let me get rid of this just so I can see everything clear. All right, so calibrating a scale. So making sure that the scales used by businesses in the United States are accurate is the responsibility of the National Institute for Standards and Technology in Washington, D.C. Suppose that this organization of technicians are testing a scale by using a weight known as to weigh exactly 1,000 grams, right? So the standard deviation for the scale reading is known to be 3.1. They weigh this weight on a scale 55 times and they read the result each time. The 55 scale reading have a sample mean of X bar of 999 grams. The calibration point is set too low if the mean scale reading is less than 1,000 grams, right? So that means the scale is off. So the technicians want to perform a hypothesis test to determine whether the calibration point is set too low. All right. So again, setting up the scene is always the most important thing. So, you're gonna have to read this a couple times to see, what is their goal? What are they trying to do? All right. So, without going through all the steps here, I want to make sure we have the deeper understanding. All right. So let me walk you through all this. So as I read all this, I always start off by identifying, everything that they give me. So number one, our sample size, they tell us we're going to read 55. We're going to do this 55 times. We're going to get 55 readings. All right. So that's my N. And then my X bar from those 55 readings is 999 grams. Right? And then your mu, right, so it's known to be, bam, 1,000 grams. And this is what we're testing it against, right? Because these are the two that we're checking to see, hey, is there a significant difference? Is there a big difference between these two readings, right? And well, what else we got? We got this guy, which is so important. This is the big hitter, the population standard deviation, 3.1. All right. And then they give us the alpha level of 0.01. Right, that's our level of significance. Right. And here they want us to use something called the critical value method. And we'll talk about that. The shortcut is called the p-value method. And that's the one I showed you at the end of class. All right. So we'll look at this, we'll dive in. But the first thing I want you to know is you always need to write down all those important pieces of data. And then you ask yourself, what's the goal? What do they want? I'll tell you what they want, what they really, really want. And what they want is they want you to perform a hypothesis test. So they want you to perform a hypothesis test. Mom, you're on YouTube. Do you want to say anything to the YouTube audience? All right, YouTube, she doesn't want to talk to you right now. She'll talk to you later. Okay, I'll call you back later. Love you. Goodbye. That's my mother. So what do they want? So they want us to perform a hypothesis test. So they want us to perform a hypothesis test. And this is where you come in and you're like, oh, I know which one to use because they give me the population standard deviation. So that's how you know that you're gonna be running a z-test. And what's not fair is right now all these are like z-tests, so kind of puts you in that potential bad habit. But once everything's mixed together, people are like, wait, how do I know it's gonna be a z-test and not a t-test? And so again, in your notes, make sure it's very clear because of this, the population standard deviation. All right. So what's our goal here? All right, because again, this is helpful, this explanation part, right? If I hit this is awesome, but look what happens. It says, it gives you this, and it gives you this, but this doesn't really have a meaning behind it, right? So you have to know, like using all this information, right? Let me write it out. What does this actually mean for the problem? Well, the first thing we're trying to see is, is the mean weight, is it is it close enough to 1,000 grams? Because if that mean weight of those 55 readings is close enough to 1,000, we say, you know what? The scale's fine. And I don't need to calibrate it, right? But this one is saying, you know what? After all my readings, what I'm finding is that based on this sample space, I'm seeing a significant difference. It's reading a little bit too low, right? And in real life, that could um, that could impact whatever it is that you're doing. So if we're talking about this national scale, and let's say I don't know what this is exactly used for, but let's say we're doing for like the truck driving and they're doing taxes and uh, they have to pay related to weight. And if this is off by weight, right, they're losing out on a lot of money over time. Depending on whatever the that you're trying to do or you're using this for, right? So again, you want to make sure that you have really strong evidence before you go and change something. So that's what this is. That's what the alternate hypothesis is for, to see, do I have really strong evidence to say, hey, you know what? This needs to be adjusted, or else something bad's going to happen. Okay, so again, take time and really make sure that you understand this part. Not only, oops, and I already did something dumb already because I was looking, my eyes are all over the place and I'm thinking of too many places. These are always going to match. So shame on me. I'm always comparing it to the mean of the population. So that's 1,000. These are always the same. All right. I was thinking, I was using this number right here, which is wrong. We're never going to use a sample mean. Okay. So now when I do my drawing, this is going to be a left tail test because it's less than, right? And what they're going to want you to find is this critical value. And that's what we're doing in class. This is like our cutoff region. All right. And so if you're with me earlier, Shai, I think it was you that caught my drawing. Um, and you saw when I did my drawing that I did not uh, draw. I drew two tails instead of one. So you're always going to look at this to get your drawing. So what I want you to do is do me a favor and copy down this table. This is going to be our cheat code, right? So go ahead, take a picture of it or copy this down. And this is going to be our cheat code, just so you don't have to use the calculator, but I'll show you how to use the calculator anyways. And I've shown this already. It's basically just finding the Z score, all right? But because your calculators are so different, I just want to make the playing field equal and just provide this for you. So how does this work? So the first thing you do using this table is you say, okay, what's my alpha level? And notice my alpha level is 0.01. So there's 0.01, bam. And then you have to decide, all right, what kind of tail do I have? Do I have a left tail, right tail, or two-tailed? In this case, we have a left tail. And so this is the number that we're going to use. So this is our critical value that corresponds to that left tail. All right, so let me give you a minute or two to copy that down. And so if you're watching this later on YouTube or wherever you're watching this, fast forward and make sure you copy this down too. This might be useful to you. All right, so I'll give you guys that are here some time to copy that down. And so again, this is a table I'll provide. If you want to do it on the calculator, for those of you that aren't in my class, all you're doing is using the inverse norm program. All right. And then you just tell your calculator the area to the left. And the reason you're saying it's a left area is because that is our drawing, right? Our drawing is to the left. And then you just plug in your alpha. And what's nice is it's going to give you the same exact number on your calculator. So again, all we're using is inverse norm, but these numbers are used so often. I was like, I'll just provide you with these numbers for those of you that want to do that. But again, this table, let me write this down on here. This table is essentially, basically, this is just inverse norm. All right. But what's crucial is that you're drawing this part is correct, because if I do two tails like I did in class when I fell asleep, all of a sudden, right, something bad might happen. And when I did that, what would have ended up happening is instead of say getting this, it would have given me this. All right. And so again, I don't want us to make that mistake. Okay. So there is our critical value. So let me write that down. So that's our critical value, negative 2.3. So this is negative 2.326. All right, so now the next thing we're going to do, so this is our critical value. How do you find the critical value? You could use this nice table, or you could use inverse norm. Same thing. All right, so now what we do is we're going to get our test statistic. So this is what I see a lot of my online students using, which is great. But you don't have to use this formula because we have a program. If you want to use this formula, that's great, right? But there's a chance you could make a calculator error or do something silly, right? So I just like dumping this into my z-test. So me personally, I prefer, hey, let's just use our calculator. Let's just use z-test. So do that with me. So let's go to z-test and we're going to plug all this in. All right. So I'm not gonna show this part on the screen because I noticed when I switch screens, all my drawing goes away. All this information goes away. So I'll figure out a way later to add to do like a double screen so I could record that as well. And I know how to do it, but it'll take a little bit too much time. So I'll set it up ahead of time. All right. So do it with me. Stat, test, and it's number one, z-test. And again, I already have a video on this. The first one, your mu is 1,000. Your population standard deviation is 3.1. Your X bar is 999. And your N is 300, or sorry, 55. And we are using the middle one because it's a left tail test. So make sure that middle one is highlighted. All right. So now that I have all my information, I hit calculate and I end up with negative 2.39. So can you guys give me a thumbs up if that's what you're getting? A negative 2.39. Check. Check to see. All right, cool. I got some thumbs up and middle fingers. All right. So if I look at this, negative 2.39, where is that? Is that to the left? Because it's really close to this, or is it to the right?
To the left.
To the left, it's a little bit smaller. Good. So it's a little bit, so that's like right, it's really close. So this is a close call right here. So that's like right here. So I'll just kind of over exaggerate. So that I'll put my little X. So this right here is my test statistic. All right, that I just calculated. And notice it falls inside my shaded region, right? It fell inside of the shaded region. So this is what we call this shaded region. This is what we call our rejection region. So that's what we call rejection region because it tells us to reject H naught. So when it says reject H naught, that means I'm canceling this one. I'm not going with this one. I'm going with this. And what this is telling me is that, hey, those values, those readings that you're getting, they're significantly less than 1,000. So you better calibrate your little machine there because it's not doing the correct reading. And Valerie's throwing some bonus points and she's saying in your TI84 calculator, it shows you the graph by hitting draw instead of calculate, which is absolutely cool, right? It draws it for you. Absolutely. All right. And so does that make sense, like how what this does in terms of how it tells you whether you're rejecting this or not? Are we good there? Okay, cool. And then see the chat. All right. So now what I want to do, and so for the last piece of business, I already said out loud, but just so you could copy it. So we're just saying, yeah, there is enough evidence to conclude that the calibration point is set too low. And that's what we said, right? So hopefully this is making much more sense than it did in class. And so again, it just takes time. It takes a few times to look at it before it starts setting it. All right, let's do one where it gives us like a list of values now. Okay, just so we could play with that. So let's do that. So let's go ahead and look at number 6. I think it's number 6. Let me see if I can find a different one, because we did that one. Well, we did that one too in class. Does this one give us? No, they don't. Let's just do it again for that. Just to make sure we really understand now. Because at first, maybe we were just copying notes, but we didn't really understand. But now, let's make sure we truly understand now that we're getting a better idea of it all. All right, so as you're doing that, let me see. Give me a second. I want to share. Where's my calculator? Let me get things ready so I could share both things at once. Just give me a second here. Share this. So sorry, you might have to like screen it or zoom into your phone or whatever you're watching. All right, and then let me do a new share. I hope this works. All right, now can you see both?
Yes.
All right, thank you. All right, so what I would do, my calculator, let me go home. So I'm gonna go to stat here, edit, and let me punch everything in. I don't care what list you use, so 11.7, 14.4, 11.6, 14.6, 15.9, 8.7. Hello, you're on YouTube, so if you'll do me the favor and call Luce's phone, and I'll be with you shortly. Thank you very much. Getting a lot of phone calls, guys. I must be very popular. 12.5, my family loves me. Let's see, 8.9, 11.4, 17.7, 9.8, and 15.7. All right, so those are my 12 values. I plug them into L3. All right, explain why it's necessary to check that the population is approximately normal. So it's necessary because, boom, our sample size is too small. I do not have 30 values. So we talked about that. This case, notice there's no clear outliers. So we say it is reasonable to assume that it's approximately normal. And now we start the process. So now we want to state the null and alternate hypothesis. So let's look at what's going on. So you got these EPA, you got these readings of water. So the amount of lead in each water. So this tells us how many micrograms per liter are in each one of those samples. And that's what I entered into L3. Right. So someone is asking a great question. Does the order matter in which we, enter these values? The order does not matter whatsoever. Great question. All right. Because what your calculator is going to do is it's going to give us the X bar, right? The sample mean. And then it's also going to give us, if needed, the sample standard deviation. All right. If needed. All right. So the null hypothesis here is we're assuming, is the average equal to 15? All right. So here, put mu equal to 15, right? But what we do is we want to see, hopefully, that it's less than 15, because if it's less than 15, what that means is that the amount of lead in these samples is less than 15 grams. And that would say, yes, it does meet the standards, right? So that's why we chose this one. All right, we have less than, so we know this is a left-tailed test. All right, so for those of you doing this one with me. All right, so we draw this and we have two methods to use. Here it looks like, let's see, what method are they going to use? Use the p-value method. So this is the faster method, the p-value method. All right, so the first thing they want is they want us to compute the test statistic. So whenever they ask you for the test statistic, you're using the z-test, right? So let me go home, second quit. And so we go to stat, test, and z-test. And then we plug in all our information, right? But make sure that data is highlighted because that's what they give us. They give us data. For our situation, we're using L3. So I'm using L3. And then I hit done. And so the mean I'm comparing it to is 15. And the standard deviation, population standard deviation they give me is 5. So that is 5. And so notice there's my test statistic right here. Negative, because it's less than 1.56. And it wants us to round to 2 decimal places. All right, so there's our test statistic. The p-value is also given here right below. So our p-value is 0.0588 and wants you to round to 4 decimal places. All right, so there it is. And then we go to number 6. So number 6 tells us, do we reject H naught? So remember, the alpha level we're using is 0.01. So what would you guys say? Do I reject? Do I reject? What would you guys say based on our discussion, based on everything we've done? So our p-value is 0.0588. Our alpha is 0.01. What would you say? Do we reject?
Yes.
Okay, we got a yes. Do we have anyone that wants to fight? Or does everyone say yes? All right, so on this one, and let me write down our rules, or actually, let's see what the chat says. All right, we have someone that agrees, we have someone that disagrees. Good. So we got people on both sides of the fence. So let's look. So remember, if P is less than alpha, we reject H naught. So our P is 0.0588, which is 5.88% if I were to look at that as a percent. And then 0.01 is 1%. So this is actually bigger, right? Our P is bigger. So we do not reject because we only reject if P is less than. So our P is actually bigger. So write that down. So here we do not reject. Cool. And then, so because we do not reject, what we say is, hey, there is not enough evidence to conclude that the mean lead amount is less than. Because if you remember our claim that we stated earlier, we have our null hypothesis that said it was equal to 15, and then we had our alternate hypothesis that said that the mean was less than 15. So when we don't reject, so we fail to reject, that means we don't reject, right? We fail to reject H naught. So we fail to reject H naught. So that means we're going with this. We're not saying this is false, but we're saying, you know what, we don't have enough evidence to support this. So our evidence doesn't back this up. Right? So this is what we're going with. All right, Valerie.
So
Question.
whenever they give us that set of numbers is when we use the data
Yeah,
and
exactly.
the L1 or
And in my case, I put it in L3, but it doesn't matter. As long as you tell your calculator where it's located.
okay.
Great. Great, great, great. And that's Toby. He's excited in the background. All right, so let's take a look here. So let me hit